Looking at the formative from May 12th, 11th, 12th, or 13th, depending on your class, here are the substitution examples. So, two different strategies to use when you have different forms. So here, both forms are in slope-intercept. Here you have a form in slope-intercept and one in standard. So let's start with number 3. And since y is equal to negative 7x minus 5, we can substitute all of that in for anywhere there's a y, like the y in the other equation. So when we do that, we get negative 7x minus 5 equals 8x minus 5. From there, I just need to solve. So now I have an equation just with x's in it. So if I add 5 to both sides, I get negative 7x equals 8x plus 0. And a lot of people get confused when they see something like this, but if you just add 7x to both sides, you end up getting 0 on this side, and that's the part that people forget to just show that this is equal to 0, and then drop down the equals and get 15x. And if you just think logically, and you go through the steps of solving, you would have to divide both sides by 15. And we would get x here because the 15s would cancel. And we get 0 divided by 15, which is 0. So we get x equals 0. So you just have to finish the process of solving the equation here. And then once you have that x value, you're going to plug it into both x on the top equation and x on the bottom equation. So the first one, y equals negative 7 times 0 minus 5. If I do negative 7 times 0, it's 0, subtract 5, and I get negative 5. So I'm saying y equals negative 5. I should also get the same thing on the bottom equation, which I'll do in green so we can distinguish. Y equals 8 times 0 minus 5. 8 times 0 is 0, minus 5 is negative 5. So once you have that, we have our solution, 0, comma, negative 5. So again, just to recap, if you have slope-intercept form, take the one equation, plug it in for the opposite y, and then solve. For one of each, we have standard form and slope-intercept form. Again, we know what y equals in terms of x, and we have a y in the other equation. It's going to squeeze into that little space. So in order to do that, what I prefer people do is they start writing out that standard form equation, but instead of the y, put a nice wide parenthesis. All right, so it's negative 5x minus 6 times y equals negative 5. Negative 5x minus 6 times y equals negative 5. It's just mirroring that same thing, except the y becomes this larger space where we can then take all of this and plug it in. Negative 7x plus 7. Now this problem, or this type of problem from here, should look pretty familiar. This is solving a single variable equation, and we want to make sure that we follow the right steps. So first of all, oops, give myself a little space. I will distribute the negative 6. Okay, and from there I'm going to drop down the negative 5x. I have negative 6 times negative 7, which is a plus 42, keep the x. Negative 6 times positive 7 is minus 42. Drop the equals, still equal to negative 5. I can combine these two things because they're on the same side. I get 37x. If I add 42 to both sides, I get 37x equals 37, looking good. Divide by 37, and x equals 1. So a lot like that previous problem, we first found x, and then now we're going to plug in that x. In this case, we could plug it into either equation. I'm going to use just the top to start. So it's y equals -7 times 1 plus 7. -7 times 1 is -7 plus 7 is 0. So I think my answer is 1, 0. I'm going to put a question mark in there until I can confirm it. And I'm going to confirm it by using the bottom equation. I'm going to take my 1 and plug it in here. I'm going to take my 0 and plug it in here. Well, that's confusing. Okay, and that looks like this. I'll use a different color. Haven't used orange on this problem. -5 times 1 minus 6 times 0 equals -5. -5 times 1 and minus 6 times 0. -5 equals -5. That's true. And when I get a true statement with the point that I think is the solution, that confirms that is the solution.